Welcome to class today. Today we're going to be looking at section 2.7, and this is going to be dealing with different operations of functions, specifically adding, subtracting, multiplying, dividing, and also looking at function composition and their domains with both equations and also with graphs and tables. So to start off, I have a couple here for a startup that I'd like for us to try. So if you'll pause this and try it and then check your answers. Okay, you can see your answers here on the first one. This is going to indicate we're going to move left 3, reflection in the x-axis, and this is going to be down 2. And our parent graph on this one would be x squared. Okay, this one we're going to reflect it in the y-axis because the negative is inside the function. And this is going to move it up 1, and our parent graph is going to be the square root graph. This one, we're going to have a vertical stretch by a factor of 2, and we're going to move it down 4, and our parent graph would be the absolute value of x. This one, we're going to move it right 2, and this is going to be a vertical shrink by a factor of 1/4, and our parent graph here is going to be x to the third. As far as the even, odd, or neither, to determine this, you plug negative x in and simplify. So this part would stay negative. This one become positive. So when you compare your signs, you're exactly the opposite. So you're the negative of the original, and therefore it would be an odd function. Okay, so as I said today, we're going to be looking at different ways of combining functions together and different operations on functions. We're going to start with sum, differences, products, and quotients. Basically, you're just combining these together in the indicated operation. The domain is something you need to be careful about because with each of these, when you add two functions together, you basically combine their domain. So if you have a restriction for f and you have a restriction for g, when you combine f plus g together, or f minus g, or f times g, or even f divided by g, you're going to end up with their domain being the intersection of the domains of each of those. So if I have a restriction for one and a restriction for the other, then my new domain is going to be the combination of those restrictions. The one additional thing down here on the quotient that you have to pick up is you have to always make sure that your denominator is not now going to be 0. Okay, so if we look at this example here, we want to find these different functions. So if I've got the function f plus g, we're not going to focus on a lot of simplification with this. So I'm going to have 1 over x minus 2, and I'm going to add to that the square root of x. I could get a common denominator and so forth, but we're just not going to spend time doing that right now. As far as the domain itself, I've got a couple things that I pick up. One here, x has to be positive, and then x cannot be 2. And we've talked about why this is. You can't take the square root of a negative number, and you can't divide by 0. So because of that, WebAssign is going to ask that you write this domain in interval notation. So if I'm looking at greater than or equal to 0 and not equal to 2, then I'm going to start with 0, and I'm going to go up to 2, and then I'm going to union that with 2 to infinity. So that's the way I would write from x greater than or equal to 0 and x not equal to 2 in interval notation. F minus g is actually pretty much the same thing with just a minus sign, and it's going to have the same domain, so I'm not going to go through that again. On C, if we're going to look at f times g, then literally I'm going to multiply the two together. So I'm going to end up with the square root of x over x minus 2. So for the domain is going to stay the same when they're multiplied together. And then on D, f divided by g, that's going to be 1 over x minus 2, and all that over the square root of x. So I'm going to do keep, change, and then flip. So I end up with this should be an x, 1 over the square root of x times x minus 2. So as far as the domain on this one goes, it's going to be all the same things that we had here, except we can't let x be 0, because if I let x be 0, I'm going to have a division by 0. So my domain for this one is going to be from 0 to 2, and I'm going to union that with 2 to infinity, but I need a parenthesis on this 0 instead of a bracket. All right, so I'm going to kind of come up here to do this part. I'm running out of space just a little bit here, but looking at this, all I'm doing here is kind of taking these same functions and plugging 4 into them. So if I do the f plus g, then I'm going to use this function here and plug 4 in. So f plus g of 4, if I plug 4 in here, I'm going to have 1 over 2 plus the square root of 4. So that's going to be 1/2 plus 2, or 5/2. If I do f minus g of 4, then I'm going to have 1/2 minus the square root of 4. So I'm going to get negative 1/2, sorry, negative 3/2. And if I do f times g of 4, again using this one here, I'm going to have the square root of 4 over 4 minus 2. That's going to be 2 over 2, or 1. And then last, f divided by g, I'm going to be using this function here. So I'm going to have 1 over the square root of 4 times 4 minus 2. So that's going to be 1 over 2 times 2, or 1/4. So I'm including several examples here today with this. If you feel like you understand it, certainly you don't have to go through every example. Looking at this one, we're going to do the same thing, except here we have just basically 2 lines that we're going to be combining together. So if I do f plus g, I'm just literally going to add these 2 together, and I'm going to get 9x. For the domain, there's no denominators, there's no radicals, so my domain would just be all real numbers. So I'm subtracting here, I'm going to have x minus 8x, so negative 7x, and the domain there is also going to be all real numbers. So it's always nice when we don't have radicals and denominators to have to deal with. Here I'm going to do x times 8x, so I'm going to get 8x squared. And the domain for 8x squared would just be all real numbers again. This one, we've got our f, going back here, our f is x. So we've got x over 8x. This does simplify to 1 over 8, but we need to be careful about this, because if once we simplify it and it looks like 1 over 8, it looks like it would be all real numbers, but we do need to make sure we carry forth the restriction because of g being in the denominator. So since g is here in the denominator, x is not going to be able to be 0, or we'd have division by 0. So we actually, on our domain for this, do need to restrict it and say that x cannot be 0 with this one. Okay, this one is already combined together. It's just asking us for the domain on it. We've got 2 separate functions combined together, so we need to look at their individual domains. For this one, we would take what's underneath the radical and set it greater than or equal to 0. So we know that it has to be positive or 0 for this part to work. So on this one, we're going to do the same thing. Okay, so we get 9 is greater than or equal to x. I like to turn that around and say x is less than or equal to 9. I like to have my variable here. Just make sure that since it's pointing to the x, when we turn it around, it's still pointing to the x. So my combined domain, if I'm going to combine these 2 together, x has to be greater than or equal to 0, but it also has to be less than or equal to 9. So when I write that as an interval notation, I'm going to have from 0 to 9. Okay, moving on. Again, try these and check your answers on any that you feel comfortable with. Here, if we're going to combine these together, we've got 8 plus x over 9. So 8 over x plus 9, and then x over x plus 9. We have like denominators, so we can go ahead and combine these together. And we get a domain restriction, and we get a function here of x, 8 plus x over x plus 9. As far as the domain restriction on this one, we just need to make sure that we restrict it so that x cannot be -9, set the denominator equal to 0. And in doing that, we're going to write it in interval notation as -infinity to -9 and -9 to infinity. The subtraction part is pretty much the same. In most cases, it's going to be, so we're going to have 8 minus x over x plus 9, same domain restriction for the same reason. Okay, here if we multiply the two together, multiply the numerators and multiply the denominators. Okay, so we're going to get the same domain restriction. We can't have 0 in the denominator, so we're still going to have to exclude -9. So it's going to be from -infinity to -9, and then -9 to infinity. And I just noticed this should be a negative here. So moving on to the division. When we do the division here, f was 8 over x plus 9. We're going to divide that by x over x plus 9. So we're going to do keep, change, and flip. These are the same here, so those will cancel. We get 8 over x. So we have to kind of look at this and see, because we have x here in the denominator, we're going to have to exclude 0. 0 is not going to be able to be a value that we use. And we don't lose our original restriction. So our original restriction said that x could not be -9. So we're going to have both of these combined together. So our intervals are going to be from -infinity to -9, from -9 to 0, and then from 0 to infinity. And if you have trouble writing it like that, what I would suggest is to think of your number line. We're excluding the value -9 and the value 0, and it's going to be everything else. So I think sometimes when you see it visually, it's a little easier to think how you're going to write that. So this interval would be -infinity to -9. This one would be -9 to 0, and this would be 0 to infinity. So really the only difficult part to adding, subtracting, multiplying, and dividing is just kind of keeping up with the domain restrictions that you might have. So I want to move on to talking about composition of functions. Composition of functions, when we combine two functions together and we apply one function to it, and then we apply a second function, and that kind of gives us a combined or composite function to work with. So when we do this, it's like you have this input that you put in, and the first function is going to do something to it, and it gives us an output. Then we take that output and put it into the next function, and that's going to do something to it, and then give us our finished output. And that's kind of, and we can string along several different functions together to make this happen. So notationally, you can see what we refer to as FOG, which is f of g of x, or my preferred notation is this one, but you're going to see both interchangeably. So f of g of x. Always start with this function and put it into the outer function. So we're going to start with this function and put it into this outer function. So that's kind of the order of it. You work from the inside out in terms of how to plug it in when you do composition of functions. Okay, so a domain is something that we'll be keeping up with here. So basically, if you have any kind of restriction on your input originally, you're going to have to keep that with you. And then once you have your combined function, if you pick up any additional restrictions, then you're also going to have to include that as well. Okay, so let's start with some very basic ones. Here, if we've got f of g, as I said, that's the same thing as f of g of x. If you're more familiar with that notation, that tells me I'm going to take the g function, I'm going to put it into the f function. So I'm going to take this and I'm going to substitute it over here in the place of my x. So I'm going to have x minus 3 and that whole thing squared. So you can simplify this or not. It's kind of up to you. I'm not going to be too strict about simplification here. So this would be our combined function f of g. And as far as the domain on these, this particular problem, we didn't have any original domain restrictions, and we don't really have any restrictions here because we don't have a denominator, we don't have a radical. So our domain on this would be negative infinity to positive infinity. If I look at g of f, this is taking the f function and putting it into g. So if I take this whole thing here, put it in here where the x is, I'm going to have x squared minus 3. Again, I don't really have any domain restrictions to worry with, and so it's going to be negative infinity to positive infinity. If I have a number, there's a couple ways you can do this. One, you can go to these simplified formulas that you've just come up with. The other would be to just simply take 5 and put it into g, and then take that answer and put it into f. So if I'm doing g of 5 is going to be 2. 5 minus 3 is 2. So then I'm going to put 2 in here, and I'm going to get 4 as my answer. It would be the same if I were to go and plug in 5 here. I would have 25 minus 30 plus 9, and that's going to give me 4. So whichever way is easier for you. Here, g of f of 7, I'm going to put 7 into f. So I'll get 49, and then 49 minus 3 will give me 46. If I want to plug it in here, that's going to give me 49 minus 3 would be 46. Okay, so here's one I'd like for us to try. We're going to do f of g of x. So I'm going to take the g function and put it into the f function. So when I do that, I'm going to take this entire function here and I'm going to put it in where the x is. So I'm going to have 2x squared minus 1, and then I'm going to have the plus 2. So this is representing where the x was, and I'm substituting this whole thing for that. I'm going to simplify underneath this radical, and I'm going to get 2x squared plus 1. On this one, I'm going to put my f, take my f and put it into the g. So I'm going to take this f function and put it into the g. Okay, I'll simplify here because the square and the square root cancel each other. So I get 2x plus 3. Okay, you can do f of x. It just means you're going to put f into itself. So if I'm going to put f into itself, I'm going to put it in here. So I'm going to have the square root of the square root of x plus 2 and then plus 2. So I replace the x with this entire function here. We're not going to try to simplify that. In fact, there's not much you can do to it. If I put g into g, I'm going to have 2 times 2x squared minus 1 squared minus 1. And if it's a polynomial like this, I would like for you to go ahead and simplify it. This would be, fold this out, will be 4x squared minus, actually 4x to the 4th minus 4x squared plus 1. And you could get what I just did by doing 2x squared minus 1 times 2x squared minus 1. So this will be 2 times, actually, this will be 8x to the 4th minus 8x squared plus 2 minus 1. So 8x to the 4th minus 8x squared plus 1. Okay, we have another one to work with here. And again, I just wanted to include several examples because I think especially domain can be an issue with this. Here we're going to put the g into the f. I'm going to take this entire function and put it into the square root of x. So I'm going to have the square root of the square root of 2 minus x. Okay, since everything is underneath 2 square roots, that's going to be the same thing as the 4th root of 2 minus x. Because keep in mind, each one of these radicals could be written as to the 1/2 power. So that would be the same thing as 2 minus x to the 1/4, which is the 4th root. As far as the domain on this one, we need to make sure that this is greater than or equal to 0. So 2 has to be greater than or equal to x, which means x has to be less than or equal to 2. So I'm going to have from negative infinity to 2. Okay, for b, we're going to do g of f. So I'm going to take the f function and put it into the g. So I'm going to have the square root of 2 minus the square root of x, all this underneath. So I've got a couple things I need to make sure of for the domain here. I need to make sure that x is greater than or equal to 0 for the domain part here. I also need to make sure that all of this is positive as well. So I'm going to have 2 minus the square root of x also has to be greater than or equal to 0. So I'll solve this, square both sides. So I've got 4 has to be greater than or equal to x. So I have a combined domain of this part and this part, which is the same as less than or equal to 4. So x would have to be greater than or equal to 0, and it also has to be less than or equal to 4. So we're going to go from 0 to 4 for the domain for part B. Okay, part C, if we do f of x, then I'm going to take this function and put it into itself. So I get the square root of the square root of x, which is the same thing as the 4th root of x. The domain there, we just need to make sure that this is positive. So I'm going to have x is greater than or equal to 0, which would be 0 to infinity. Okay, part D, we've got g of g. So I'm going to take this function and put it into itself. So I've got 2 minus the square root of 2 minus x. So for the domain on this one, I've got a couple things to consider. I've got to make sure that the 2 minus x is greater than or equal to 0. And I've got to make sure the 2 minus the square root of 2 minus x is greater than or equal to 0. So I've got to make sure this is greater than or equal to 0, and I've got to make sure this is greater than or equal to 0. So here I'm just going to move this and work with it. So I'm going to square both sides. So I'm going to have 4 is greater than or equal to 2 minus x, because if I'm squaring both sides, that's going to cancel the radical there. So here I'm going to move my x over here and move my 4 over there. So I get x has to be greater than or equal to -2. And I've also got that x has to be less than or equal to 2. So my combined domain, if I combine this one with this one, is going to be from -2 to 2 with brackets on each. Okay, if we try this one, I would encourage you to try it on your own and then come back and check your answers here. If you're not comfortable with it, then just listen as we go through this example. We're going to do f of g, then we're going to put g into f. So I'm going to take this entire function and put it into f here. So my function is going to be 2x minus 1 over 2x minus 1 plus 1. So 2x minus 1 over 2x. As far as the domain, I have to consider what my original domain was. So I have to look at this g. So g had no domain restriction, so I'm good with that. And then I have to look at this and see, did I pick up anything additional? I have to exclude x, 0, because I've got this x in the denominator. So my domain is going to be x is not 0. So negative infinity to 0 and 0 to infinity. Okay, here if I'm going to do g of f, I'm going to put the f into the g. So I'm going to have 2 times x over x plus 1 and then minus 1. So that'll be 2x over x plus 1 minus 1. And again, I'm not too concerned in this section about simplification. The main thing here is that I need to make sure that when I look back here at the f, that was my original function. I had a domain restriction that x could not be -1. And I actually continue with that same domain restriction so I don't pick up anything new. So my domain restriction would be negative infinity to -1 and then -1 to infinity. Okay, f of f, I'm going to put the f function into f. So this one does get a little complicated. So I'm going to have x over x plus 1. So that goes in the place of the x. And then I'm going to have x over x plus 1 and then plus 1. So x over x plus 1. I'm going to get a common denominator here just because it's going to help us. So I'll have x plus 1 in the denominator, and the numerator is going to be x plus x will be 2x plus 1. So I'm going to do keep, change, flip. Those cancel, and so I have x over 2x plus 1. So when I go to do the domain for this one, the domain for this one, I need to consider any domain restrictions that were on the original f function that I started with. So I had a domain restriction that x could not be -1, but I also pick up a domain restriction here because 2x plus 1 also cannot be equal to 0. Okay, so I'm going to get 2x is not -1, so x is not -1/2. So I've got to exclude both -1/2 and -1. So I'm going to do negative infinity to -1, -1 to -1/2, and then -1/2 to infinity for my domain restrictions on this one. And then finally, last but not least, g of g. So I'm going to take this function, which is just simply a line, and put it into itself. So I'm going to have 2 times 2x minus 1 minus 1. So 4x minus 2 minus 1. And that's going to give me 4x minus 3. So that's my composite function, the g of g. And thankfully, I didn't have any domain restrictions on g to begin with, and I don't have any domain restrictions on the composite function. So one thing to keep in mind here is on the domain restrictions, you need to look at your final simplified expression. You also need to look at the first function that you start with to pick up any domain restrictions with that. Okay, so we can combine more than 2 functions together, which is what we've been doing, and this would be combining to get 3 composite functions. So on this one, if I'm going to combine these together, I'm going to start with h and put it into g, and I'm going to put g and put that into f. So starting with h, putting it into g, I'm going to have x plus 3 to the 10th. And I'm going to take that and put it in here. So I'm going to have x plus 3 to the 10th divided by x plus 3 to the 10th plus 1. And I'm not concerned that you simplify that any further, so that would be your final answer. Other times you're asked to break a composite function up into the 2 individual functions. So here we want to find an f function and a g function such that if we combine them together as f of g of x, meaning we're going to put the g into the f, we end up with this composite function here. So to a certain extent, it's trial and error. You want to kind of look to what's inside to be the starting function. So I'm going to let the x plus 9 be the g, and then I'm going to put that into a function that's the 4th root of x. And just double check it. Like if I were to put this in, I would get the fourth root of x plus 9, and that's what I'm looking to find there. Okay, here are a couple others. If I'm going to do this, I need to find my f and my g function so that f of g of x is going to equal x minus 3 and all that to the 7th power. So my g function, I'm going to let be the x minus 3, and the f function that is being put into is going to be the x to the 7th. Here on this one, again, we're doing the f of g. So my f function on this one, I always like to start with the g function actually. So I'm going to start with the x plus 6, and I want to put that into f. So I'm going to let f be 1 over x. These do not necessarily have unique solutions. So there are other possible answers. This is, I think, the more obvious answer. Okay, so here's one for you to practice with determining, and this one actually has three functions that are being put together. So we need to find the f, the g, and the h. So see if you can find those. Okay, we want to start with the most interior function. So I'm going to let the h be 3 plus the square root of x. And then I'm going to let g be x squared. And then I'm going to let f be 2 over x. Now, there are alternatives to doing this. You could have set it up and said let h be the square root of x, and then we could let g be 3 plus x, and then we could let f be 2 over x squared. So there's different ways to set it up, and you can still end up at the same place. So understand that there's not just one correct answer. Okay, you can do function composition from a graph. So if we look at this graph here, we want to find f of g of 4. So this is going to be my x that I start out with, and I want to read off the g graph first and then the f graph. So I'm going to call this part A here, f of g of 4. So I would say keep yourself organized when you do this. These are not hard, but they're easy to make careless mistakes on. So I'm going to go where x is 4. So 1, 2, 3, 4. And then I'm going to go up to the g function. So g is my blue graph. So I'm going to go to 4 on the x-axis, and I'm going to go up to the blue graph, and I'm going to read that value off. So that value is 3. So what I'm going to do is I'm going to actually mark that out and put a 3 here so that I know now I need to find f of 3. So I'm going to do the same thing. I'm going to go to where x is 3, except this time I'm going to read the f graph, which is the red graph, and so I'm going to get 0 for my answer. And that's what we should have gotten there. Okay, so I want you to try these. If you're not comfortable with it, then just listen. If you are comfortable, then pause it and try them. Here we're going to do f of 4. So f of 4, I'm going to start at 4. And since we're talking about f, I'm going to go to the red graph. So f of 4 is go across here 2. So this is going to get replaced by 2. So now I need to find f of 2. So f of 2 is actually negative 2. On this one, I'm using the G graph, so I'm going to go to where x is 1, except this time I'm going to use the G, which is the blue one, go up and over, so this value is 4. So we'll replace this with 4. So now I've got to find G of 4. So go over to 4 and go to the blue graph, and that value is 3. And then finally here, if we go to 2 and we use the G, that's the blue graph, we're going to be at 5. So all this is 5. So now I need f of 5. So f of 5, go over to 5 on the x-axis and go up and over, and so that value is going to be 4. So we can also do function composition using a table. Very similar as far as how it works. This is going to be, we're going to start out with f of 5. Again, I prefer this notation to keep myself kind of organized as to where I need to start. So I'm going to start with f of 5. So I'm going to go to where x is 5, and I'm going to get the f function value. So that's going to be 6. So I'm going to replace all of this with 6. And then I'm going to repeat that process. I'm going to go to where x is 6, and I'm going to get the f function there, which is 2. And so 2 is going to be my final answer for that. On the next one, f of g of 4, I'm going to go to where x is 4. I'm going to get the g value, which is 2. So now I need to find f of 2. So f of 2, go to where x is 2 and take the f function value, and that's going to be 2. Next we have g of f of 3. So I'm going to go to where x is 3 and get the f function, which is 3. And then I need to find g of 3. Okay, so I'll go to where x is 3, and I'm going to get the g function, and that's going to be 6. Okay, over here, I'm going to start with where x is 5, and I'm going to get the f function, so that's going to be 6. So I need to then find g of 6. G of 6 is going to be 4. And then finally, g of 2, we start with where x is 2, and then I'm going to find g of 2, which is 5. Okay, so g of 5, I'm going to come over here to where x is 5. So g of 5 is 1. So that finishes this section for us today. As always, feel free to join our Zoom sessions on Tuesday and Thursday mornings at 8 o'clock. Bring with you any questions that you may have. If you're not bringing questions, then I'll always have some problems prepared for us to work through, but I would like to know which problems you would like to see worked. Thank you and have a good day.